Hey guys, this is Worm from Worm's Maths Academy. Finally going to have a crack at this exam. Sorry to those of you who've asked me to do the exam earlier, but um, my business, the week when the specialist maths exam was, on the Friday, I'm free. I have that week off because I'm rolling over. But then when it comes to the Monday, that's when my new classes start for 2022. And I've pretty much been working 7 days a week since then, up until last Sunday, where I finally got some time off. I've spent the week pretty much just lying on the couch because I'm so freaking tired. Okay, now I've heard a lot about this exam, but I haven't actually seen it. Kids keep telling me it's impossible. So they say you can't do it in the time. Let's have a look. And I've got a pretty crappy copy as well. I mean, it works. Okay, let f of x equal 1 on sec 3x plus 3 on 2, the number of asymptotes in this domain. Okay, I guess we could graph it. Also, we know if sec of 3x is equal to negative 3 on 2, there'll be an asymptote because we'll be dividing by 0. So we could do that. 1 on cos x, 1 on cos 3x equals negative 3 divided by 2. Solve, but we only want it, I think it was between negative pi on 6 and pi. 1, 1. Is there 3 solutions there? Bloody stupid thing. Yeah, there's 3 solutions. There's no horizontal asymptote because set graphs don't have horizontal asymptote, so it's just 3. Okay, the implied domain of this function. So we know cos inverse of x is defined between negative 1 and 1, so we can only find values for negative 1 is less than log e of bx, which is less than 1. I've got 1 on e when I e the outside is equal to bx, which is less than or equal to e. If I divide the b out, 1 on EB is less than x, which is less than E on B. So 1 on EB. E. Okay, the coordinates of the local maxima of this graph. Okay, so, I guess we can just sketch it. Just use x equals 1. So 1 on cos of x, that didn't work, plus 1 squared, was it plus 3? Let's go max. So negative pi, zoom out. Let's go negative 2 to 2. What the hell just happened there? Oh, negative 2 to 2. What the hell am I doing? Let's go negative 12 to 12. Okay, analysis G solve max. Okay, so I've got pi, and then I've got 3 pi, and the maximum is 1/3. So it's got to be between this one and this one. I said pi and 3 pi. Here, if k is an integer value, is there any way that I could get 3 pi? If I had 6 over 1, if I know a is 1, which we just did, There's no way here that I could get 3 pi. The only way I could do it is here, because when k is 1 and a is 1, we get 3 pi as a solution. There's lots of other ways you could have done that. You could have derived it, set it equal to 0, etc. But I think that's easiest. Okay, the imaginary part of z is greater than 0, so it's positive. Let's let z equal a plus bi. So we get a plus bi, a minus bi, over a plus bi minus a minus bi. We know on top we're going to get a squared minus b squared, no, plus b squared. And on the bottom, the a's cancel, so we get negative 2bi. Now, the imaginary part of z is greater than 0. So if we multiply this by I over I, what do we get on the bottom? We get, hang on a sec, that's the conjugate of that. So that's going to be a plus, because I'm minusing the conjugate. So I get plus 2bi. If I multiply it by I over I get a squared plus b squared over negative 2bi. So if it's an I, it's either got to be up here or down here. If we know the imaginary part of z is greater than 0, it means that b has to be positive. And if b is positive, we're going to get a negative number. So our answer has to be negative pi on 2, because it's on that axis, it's got to be this angle here. Okay, the graph of the circle is given by that, where z is a complex number. For the points on the circle, the maximum value of... Okay, so z, mod z is the distance between the origin and any point on that graph. So the furthest point is going to be there. We know the center is 2 across and root 3 up. So if I find the length of that, I get 4 plus 3 square rooted, which is root 7. And then I've got to add on another 1 for the radius. So I get root 7 plus 1. So I just found the length to the center and then added on a distance of 1. Okay, if c is a complex number, z is a complex number, and z squared is real, then the possible values of arg z are. Okay, so if I said z is r cis theta, now I'm assuming they want it in this form because we're finding z squared. We know z squared, we only really care about the argument, so we can forget about that. That's cis of 2 theta. And we want z squared to be real, so we want no imaginary components. So we can say cos 2 theta plus I sine 2 theta is z squared, and we want that to equal 0. So sine of 2 theta is 0. When does sine equal 0? 0, pi, etc. So we get 2 theta is equal to 0, pi, which is just k pi. K is an element of z. If we divide that 2 to the other side, we get theta is k pi on 2. K is an element of z. So we get A. Okay, a relation is defined parametrically by... Okay, so we know it's been translated 1 to the right and 1 down. And it's a circle with a radius of 5. Negative 1, 6. So negative, sorry, 6, 6, negative 1. That's going to be that point there. 1, 4. That's got a radius of 5, and that's got a radius of 5 from that center. The shortest distance along the graph from A to B is, so it's going to be that length there. We know that length is a quarter of 2 times pi times 5, which is 10 pi on 4, which is 5 pi on 2. That's a nice easy one. You could also sketch that in your graph. Euler's method with steps on approximate the solution of y equals, okay. So we know x naught is 1, y naught is 2. Step size of 0.1. So y1 is y naught plus 0.1 times f of x, y, which is 2 sine of 1. And then we know y2 is that previous value, 2 plus 0.2 sine of 1, plus our difference, 0.1 times f of that last value. So let's say, what have I got? I had 2 plus 0.1 times 2 sine of 1. And then I had that plus 0.1, that, what's going on? Plus 0.1 times y sine x. So that sine of 1.1, and we want it as a decimal, 2.362. Is that right? It's a solution, so it's a pretty good chance it's going to be. Okay, turning my phone off, stop all that buzzing. Okay, which one of the following derivatives corresponds to a graph that has no points of inflection? So these are derivatives. So the second derivative will be greater than or equal to 0 or less than or equal to 0. If I anti-diff that, I get a cubic. That's got a point of inflection. Anti-diff that, we get a cubic. So it's got to be one of these two. Let's sketch the antiderivative of that. So integral of 2x minus 3 squared plus 5 dx. So that's the original graph. Oh, I want to sketch the derivative. Dumbass. So d dx. Am I putting in the right graph? X minus 3 cubed. Okay, so if I go zoom auto, you can see the second derivative never changes sign, which is what causes a point of inflection. So that's got to be my answer. We can check the other one, x minus 3 cubed minus 12x. I think we'll see, yeah, that changes sign because it goes below the axis. Okay, differential equation has its direction field above. Let's choose a point, 1, 0. That's got a negative gradient. So if I put 1, 0 into that, it's not negative. If I put x as 1, y as 0 into that, it's positive. X is 1, y is 0, that's negative. X is 1, y is 0, that's negative. That's not. So it's one of these two. We could choose another point, 0, 1. That's got to be positive. So if I put y is 0, sorry, x is 0 and y is 1. X is 0 and y is 1. That's positive and that's positive, so that's no good to me. What about the point 1, 1? If I sub 1, 1 into here, I get 2. And if I sub 1, 1 into here, I get negative 1. We can see at 1, 1 it's negative, so it's got to be that graph there. We can test it by sketching it. What was it? Y minus 2x. That looks like it. Let's go between, I think it was negative 3, 3, negative 3 and 3, that'll do. Okay, I'm pretty sure. Yep, they look the same. IB unit vector pointing east, JB unit vector pointing north, carries 5 kilometers in the direction of south, 30 degrees to the west. So that's 30, so that's 60. They go for 5 kilometers. Okay, then they go 10 kilometers up. So we've got to add these all together. So that length there is 5 cos of 60 in the negative I direction. And then we've got a plus 10 minus 5 sine of 60 in the j direction. Yeah, that's right. Okay, what's cos of 60? It's a half, so negative 5 onto I. Think it's got to be that one. Sine of 60 is root 3 on 2, so we get 10 minus 5 root 3 on 2j. Yeah, so 11 is B. Okay, given that theta is an angle between A and B, so now cos of theta is the angle between A and B, so you've got to find the dot product, which is x minus 1, over the magnitude of that, which is x squared plus 1 square rooted, the magnitude of that, which is root 2. Phi is the angle between B and C, so cos of phi is dot product 1, dot product negative x. They're effectively the same thing in terms of magnitude, so we're going to get the same thing again, x squared plus 1, root 2. Now, if we multiply them together to find here, I can say that's negative x plus 1 and x minus 1, negative x squared minus 1, over the denominator is going to be the same, 2 x squared plus 1 when I multiply them together. So we get I think I've buggered something up. X squared plus 1, 1 plus x squared square rooted. It's the same thing. 2 times root 2 is 2. Oh, if I did a difference of 2 squares, but here if I take out a negative, I get negative x minus 1. So it's negative x minus 1 squared. So it's D. Scalar result of A in the direction of B is negative 4. So A dot B hat is negative 4. we can also say that's A dot B on the magnitude of B. The vector resolute of A in the direction of B, so we want A dot B on the magnitude of B squared times B. We know if I put that there, that is negative 4 times B, which is negative root 3I, over the magnitude of B, which is root 3. They cancel, so we just get positive 4I. Body of mass 5 kilograms acted on by a net force of F newtons. This force causes the body to move, so its velocity on a straight line of motion is given by that, where x meters is, okay. When x equals 2, F is equal to, so F is equal to ma. We know that that's 5. A we know is v dv dx, which is 2 times 3 plus 2x. So F is 5 times 2, which is 10. 3 plus 2x. F, when I sub 2 into that, what's that? 7 times 10 is 70. Diagram below shows a stationary body acted on by 4 forces whose magnitudes are in newtons. The magnitude of the force F1 newtons acting in the opposite direction of the 8 newton force. Okay. The value of F1. Alright. We know that that force and that force are the same. So F2, because it's in equilibrium, it's not traveling up or down, sine 60 is equal to 6 sine 30. What's sine of 60? Root 3 on 2. So F2 is equal to 6 sine of 30, which is 3, divided by root 3 on 2, or times 2 on root 3, which is 2 root 3. If I times it by root 3 on root 3, they cancel. So it's 2 root 3. Okay. So if we work this all out, that's 2 root 3. Okay, so we know F1 plus 6 cos of 30 is equal to 2 root 3 cos of 60 plus 8. Cos of 30 is root 3 on 2. So F1, if I multiply that by root 3 on 2, I get 3 root 3 plus equals cos of 60 we know is a half, so I get root 3 plus 8. So F1 is 8 minus 2 root 3, which is A. Okay, an object of mass m kilos slides down a smooth plane that's inclined at an angle of theta degrees to the horizontal. So let's say there's theta, mg. So we know mg sine of theta, that is, I'll just say g sine of theta, don't need to worry about the mass. G sine of theta, so acceleration is g sine of theta. If we double the angle, that angle is going to become 2 theta, so A is g sine 2 theta, which we know is 2g sine theta cos theta. We know what sine theta is. Sine theta is A over g. If we draw a triangle, theta, A, g, that side's going to be g squared minus a squared using Pythagoras. So we get 2g sine of theta, a over g, cos of theta, which is root g squared minus a squared, over G. Let's see what cancels here. That G, that G. I think it's B. 2A over G, root G squared minus A squared. Bottles of a particular brand of soft drink are labelled as having a volume of 1.25. The machine filling the bottles are normally distributed a mean of 1.26, standard deviation. Probably that 6 bottles will have a mean volume that's at least labelled 1.25. So mu is 1.26. Sigma is, that's the population proportion. We divide it by root 6. And we want to know when it's greater than 1.25. So we say norm CDF 1.25 to infinity because it was greater than 0.01, was it? Or 0.1? 0.01 divided by root 6, and the mean was 1.26, 0.9928 E. So remember your mean is 1.26. Your standard deviation of the population is 0.01. But if we want the standard deviation of the 6 bottles, it's divided by root 6. And we want to know the probability it's greater than 1.25. Okay, scientist investigates the distribution of mass of fish in a particular river. 95% confidence that 100 fish is that. The sample mean divided by the population standard deviation. Okay, so first thing, the mean is 70.2 plus 75.8 on 2, which is 73. It's a 95% confidence interval, so 1.96 times sigma on root 100, which is 10, is equal to the distance between 73 and 75.8, which is 2.8. So we can just solve that on our CAS. 1.96 times the square root of x on 10 is equal to 2.8. Solve for 20.48. Well, I buggered something up here. 2.8. 73. Gone down 2.8, not 2.8. Oh, it's just sigma on root 10. I'm thinking of methods. X divided by root 10. 4.52. Is that right? Oh, I stuffed it up. So if I did 73 divided by that, 16.16. Something's not right. Where are we? .96 times the standard deviation on root 10 is equal to the difference between those two, which is 2.8. Why have I got root 10? It's either root 100 or it's 10. There's my issue. 14.28. So I want to do 73 divided by that. 5.1. So that's on 10 or root 100. The mean unscored score of a certain task is 25, variance is 36. The score so that the mean is 30 and the variance is 49. Let S be the scales in nearest integer, blah, 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 blah. Okay, so E of S we know is M times E of X plus N. Var of S is M squared. Remember, you bring it out the front and square it. M squared var of X plus nothing. We know that's equal to 30, and we know that's equal to 49. Var of X we know is 36, and E of X we know is 30. Oh no, 25. So 25m plus n, 25x plus y equals 30, and 36x squared equals 49 x comma y. Okay. Okay, they both have to be positive, so m is 7 on 6, y is 5 on 6. So if I multiply 32 by 7 on 6 and add 5 on 6, 32 times 7 on 6 plus 5 on 6. What did I say? 32 times 7 on 6 plus 5 on 6. Get 38.16. Scaled to 38. An office has two coffee machines that operate independently of each other. The time taken for each machine to produce a coffee cup is normally distributed a mean of 30 and a standard deviation of 5. On a particular morning, a coffee cup is produced from each machine. The probability of the time taken to produce one cup of coffee will differ then 3 seconds. So we know, let's call one C1 and call the other one C2. E of C1 minus C2 is E of C1 minus E of C2, which is 30 minus 30, which is just 0. Var of C1 minus C2 is var of C1 plus var of C2. Remember, when we square that, we get a positive. Okay, the standard deviation is 525 plus 25, so it's 50. And so we know the new distribution has a mean of 0, a standard deviation of root 50, and we know it's got to differ by less than 3 seconds. So it can go 3 seconds above or 3 seconds below. So what do we say? We say norm CDF, -3 to 3. Standard deviation is root 50. Mean is 0. And that'll tell us 0.3286. that'll tell us the probability that lies within 3 seconds above or 3 seconds below. The reason we can go above and below is because they want to have a difference less than 3 seconds. So it's got to be, because I said C1 minus C2, we know C1 minus C2, yeah, it's got to be 3 seconds above or 3 seconds below to have a 3 second difference between both of them. Okay, hopefully I haven't made any mistakes. I didn't even know VCAA's put out their answers yet. So hopefully this helps future kids. I guess I'll have to do the second part soon. Thanks, bye.